Yeah, we're looking at the properties of Laplace transform. Properties of Laplace transform. This will be equal to um, Laplace of f of t x minus the fraction here minus a. That's the first one. We're going to apply that. Then second one, Laplace of Tn f of t. This will be equal to minus 1 over n. Your n is 2, 2 here. And that will be ddx differential coefficient with respect to x of Laplace of what? F of t. Okay? F of t. Okay? Then you can close this bracket here. So that's the two properties of Laplace, and we're going to apply it in the following questions here. Find the Laplace of the following questions. Okay? We're going to apply that. Yeah, let's do the first question. Laplace of f of t is equal to that, so we can Laplace of e2t sine 3t. Okay? Don't forget that the domain here will be this. Okay? Then you now write now, and that will be equal to Laplace. I'm using the first principle. Laplace of sine. That's your f of t sine 3t. Okay? So your domain now will now change from x minus the attachment of the exponential is 2t. The coefficient of t is 2. That will be x minus 2. So your domain has changed from x single to x minus 2. So that's what we have now. Then how do you go about this? I want you to note that Laplace of sine 3t is equal to, that will give you 3 over x squared plus 9. We know that this is when you have the x domain. Then finally, Laplace of sine 3t x minus 2 will now become, anywhere you see your x now will be replaced by what? X minus 2. And that will be equal to 3 over x minus 2 squared. Okay? Plus what? Plus 9. So that's just that. And that's the answer for that one. Then number 2, we have this one. That's number 2. Number 2, we can solve it in 2 ways. Question 2, Laplace of exponential 5t squared. Okay? You can also apply the first rule. You can use the first rule also for that, which will be equal to, that will be equal to Laplace of t squared. Then your x domain will now become x minus 5. Okay, Laplace of this, your x domain will now become minus what? Minus 5. Okay, and then you have to note that Laplace of t squared, okay, is equal to 2 factorial over what? Over x2 plus 1. And that's what? 2 factorial is 2 times 1 over x2 plus 1. That's 3. So let's apply that. What we just need to do, we just change the x here to x minus 5. And that's all you will do there. So we now have Laplace of exponential 5t t squared, okay, t squared will now become 2 over x minus 5, x minus 5 power 3. That's that. That's that. Okay. We can also apply the second rule. We can apply the second rule for the last question there, for that question too. We can apply another method or using second properties, using second properties. Okay. So if you want to use second properties, we have Laplace of this t squared. So this will be equal to, don't look at it, Tn. That will be equal to minus 1 power what? Power 2. Then the second differential. I didn't even put, there's a mistake here. This will be n here, n here. Okay, the second differential. Second differential. So that will be second differential, the x squared. Okay, and then of the Laplace of e5t. E5t, Laplace of e exponential, exponential 5t, Laplace of e5t. Okay, so that's how it should be. So that means the first thing we do now is getting the Laplace of what? Let's get the Laplace of this is equal to 1 minus what? This. That's that. That's Laplace of this. So let's get the first differential of this. First differential of this, x minus 5. The first differential of this will be equal to minus derivative of the denominator, which is 1, all over x minus 5 squared. This is a quotient rule. That's the first differential. Then the second differential, my u is minus 1. The u dx is 0. The u with respect to, okay. So if you want to differentiate this one second time, d dx of minus 1 over x minus 5 all squared, and that will be equal to what? X minus 5 power 2, that power 4. Power 4, okay, times v, x minus 5, that's my v, times the derivative of numerator, times 0, so everything here cancel, minus u, that's minus 1, times the derivative of the b, which will be 2 times x minus 5, okay, times 1. So, and then we now have minus times minus, that's 2. We now have 2 into bracket x minus 5 all over x minus 5 power 4. And then this one and this one will cancel. So we have 2 over what? 2 over x minus 5 power 3. This power 4, this power 1. So this one remain 3 power 3 at the denominator. So that's what we have there as the answer. And then your minus 1 squared is 1. So you can see the choice is yours to determine which one you want to use. Nobody is telling you which one to use. It's left for you to pick any of the properties and use. Okay? Then we're going to the third one here. Question 3. Laplace of t squared cos 5t. Cos 5t. Okay? So this will be equal to, according to the rules, it will be equal to minus 1 squared. My n is 2. Then the second differential, respect to x of Laplace of cos 5t. Okay? Yeah, Laplace of cos 5t. First things first, let's get the Laplace of cos 5t. Step 1, Laplace of cos 5t, and that will be equal to x over x squared plus 25. So that's that of Laplace of cos 5t. That's first step. Then the next step, can we get don't forget minus 1. Minus 1 square is 1. So this one is already become positive. Let's get the first differential. First differential of the Laplace of cos 5t, which is this s squared plus 25. And this will be equal to what? S squared plus 25. This is b squared. Okay. Then v s squared plus 25 times derivative of the numerator respect to that function, respect to x, then minus the numerator times derivative of this, and that will be equal to 2x. 2x, that's equal to 2x. Then we can open that. We open the bracket, and that will be s squared plus 25 minus 2x squared over s squared plus 25 squared. S squared, that's minus s squared plus 25 all over s squared plus 25 all squared. So that's the first differential. That's the first differential. We can do the second one again. Do it again. Respect to the function. Do it again. Minus s squared plus 25 all over s squared plus 25 all squared. So this will be equal to s squared plus 25. This is the denominator here is having square. If you square it again, making 4. So your denominator v here, that's v squared times the derivative of the numerator, that's minus 2x, then minus the numerator times derivative of the denominator, which will be 2 times 2x, 2 times 2 go to the front, okay, and then x squared plus 25 times 2x. Okay, so that's that. The only thing is just for you to do the algebra, just to do the algebra. And if you want to do the algebra, we can look at it here. S squared plus 25, s squared plus 25 is common in both sides. We can take it out. Take it out. S squared plus 25. If you take it out, then you have, it remain 1 here, so that minus 2x into bracket what? S squared plus 25. And then here, this one is already gone outside, and that will be equal to what? Minus 2x squared into brackets minus x squared plus 25. Okay? All over s squared plus 25 power 4.